So this is how it begins. Your environment opens up and presents you with a blank screen. And from this blank, empty wasteland, you're going to create a program. Now, when working in a development environment like this, we want to remember that the compiler is lying underneath there. In fact, now would be a good time to talk about the term compiler and IDE and those types of things before we really jump into this. So let's take a little sidebar. You're going to hear the word compiler an awful lot as you begin to work in this class, and a compiler is really nothing more than a tool. It is going to take your source code and turn it into an executable program. Now, when we use the word compiler, we're using it kind of loosely. A compiler very specifically takes a high-level language such as C++, something that you and I can read and understand and communicate in, and it turns it into machine language. It takes it and transfers it down into assembly-level instructions that the processor can understand it. And what it does is it makes the programmer's life easier. Instead of coding right down to the wires in assembly language, we're able to use a logical language like C++, code out our logic, and then have the compiler do the conversion process for us. We use the word compiler, but more specifically, what we work in is an IDE, or an integrated development environment. And simply that means that the text editor and coding tools and the compiler have been brought together and combined into a single piece of software. And so when you're working in Dev C++, Visual Studio, Code Blocks, whatever your compiler of choice is, you're actually working in the IDE, and the compiler is just a component of that development environment. Now, when you write your first program, or when you write any of your programs, this is what you're going to end up with. You're going to end up with a screen full of source code. And this is the logical flow of your piece of software that you're creating. And then you're going to go through a sequence of steps, some that you will see and some that the IDE will handle for you. So the first thing you do, once you have taken your you've taken your program and written out all your source code, is you're going to feed it into the compiler. Now, as I said just a second ago, the compiler is going to take your source code and turn it into something called object code. Object code is an intermediate level machine language. It is your source code, but it needs to be combined with the libraries of code that you have included in your program, or any other libraries for that matter. And so another tool comes into play, and that's called the linker. The linker takes your object code, links it with the object code of different libraries, and then compiles all that together and creates your executable. So when you are going through the steps, it's not necessary to remember all these things, but it's a good idea if you get a linker error to understand this process. If you get a linker error, what the compiler is telling you is that it can't find something that you've written. It can't find it in a library. It can't find the code anywhere. And so your first step would be to find the line that's giving you problems, go to that line in your source code, determine if it's something you wrote or if it's something that you thought you were referencing in a library, and then going back and making sure that that library is there. So let's return back to the code now. So beginning from this blank screen, now that we understand what the environment is all about, let's begin by typing in the basic structure of any program that you're going to create. The first thing that we need to add is called a Preprocessor Directive. And we're going to include IO stream, which are the basic input and output command libraries. This is going to give you your ability to gather input from your user, display output. Just innumerable things are contained in that library. So every program that you will write will include IO stream. The next thing that you have to add is a little bit advanced right now. And when we add namespace, STD, that's a standard namespace, we are doing something that's a little bit beyond our capabilities right now. We are giving a particular scope or a particular namespace, excuse me, to our program. And it's going to work within that namespace, and it's going to recognize built-in commands that already exist within that namespace. So just add that line, and as you advance a little bit more in your programming capabilities, we can have another discussion about that later on. All right, every C++ program has to have a function called main. And so main would look like that. The int to the left there indicates that this is an integer function. Again, these are all things we'll talk about as the weeks go by. It's an integer function. The name or the identifier is going to be main. The parameter list would be contained within these two parentheses, and then the opening and closing curly braces delineate the beginning and the ending of this function. So let's do this. Let's come back up here, and let's put a output statement, cout, a couple of less than symbols typed right up against each other. And something really original here. This is my first program. And then we will put return 0 because it's an integer program and we want it to return an integer. Again, something that'll come about later on. So let's execute this program. So it's compiling now, and as it has compiled, it'll execute it. Okay, oh, did you see that? Yeah, maybe you missed that. One of the things we can do, and I'm in a Windows environment, so I'm going to use the Windows command. One of the things we can do is put a pause in different places within our program to stop the program from executing and then immediately returning back to the command prompt. So I'm going to type system, pause, remembering the quotes, and we'll run it again. And that gives us the line that we see right here. Press any key to continue. So we press the key and it returns back to the environment. So this, in its most basic form, is the structure that you will use for every program that you're going to write. You will develop your main function first, because you can't test your program without that, and then add other functions on as necessary for your program's design. Now let's add one more thing before we close out this real quick lesson. Let's come in here, and we're going to make a variable, something we won't talk about just yet. We'll say integer x equals 0, and let's change this prompt. Get rid of the end line. This is exciting, isn't it? And then we'll say cn x, put another output statement. Value you typed is as if you didn't know what you just typed. We'll pretend. Okay. Now this, I've added an input statement, and it's going to ask the user to type a value. It will place the value that they type in X, We've declared X right here, and then I'm going to simply output it back to the screen. See out the value you typed is, and then the variable X is right there. So let's execute this. And there it is. Now it'll sit here all day waiting for me to type a value. It has halted the execution of the program and is simply going to wait for me to get on with it. So we'll type 99, press enter, and look at that. The value you typed is 99. This thing is a miracle. Okay, and it's, the pause caused it to stop right there. And that's that. That's your basic program. Nothing more complicated than that. When I go to execute the program in Visual Studio, which I'm using here, the key is F5, and I believe it's the same key in Dev C++. So as you write your code and you're ready to execute it, go ahead and just press F5 and it'll run. There's also buttons on the toolbar that you can click that'll do the same thing. Now, I built this program incrementally. I did just a little bit at a time, and I would suggest that as you begin to program, that you follow that same path, that you not try to type in the entire program all at once, but that you build the program sequentially, one statement, a couple statements, a logical portion at a time, and then go back and test it. That's the advantage of this integrated environment, is it allows us to very quickly see the effect of changes. When I first started programming, you made your changes, 1 or 100 lines, it didn't matter, and then you submitted your program into the processing queue. That could take anywhere from a minute to several hours before the queue brought your program up, compiled it, and then output the results. And the results didn't come back to the screen. They came out on green bar paper, and you had to go and find your printout, make sure that everything worked. And I'll tell you what, you learn to design very carefully in that environment. So good luck with this. You're going to start your programming career with something as simple as this, and I think you're going to do quite well. So we'll talk to you again.